fallen under the logic of capital and capital accumulation. This is industrial agriculture coming into its own. He says capital, largely in the form of new technologies, has displaced labor as the chief component of production in farming. Indeed, farming has become the most capital-intensive sector of the modern capitalist economy, and labor productivity there has outstripped that of industrial production. The changes in farm inputs between 1935 and 1977 are dramatic. So the percentage of the non-purchased inputs have declined by 44%. That would have, at one point included seeds, which are now purchased rather than non-purchased. Purchased inputs have increased 256%. Farm labor has declined by 3/4. Machinery has more than tripled, and agrochemicals have increased by nearly 2,000%. All of this contributing to an overall farm productivity increase of 207%. Again, rapidly exceeding the increases in productivity in the rest of the economy. The value added, meanwhile, in agriculture as of 1985, so you can think of this in terms of for every dollar you spend on food, where does it go? Roughly 13% of it to the farm. That's actually lower now than it was 25 years ago. 32% to the providers of commercial inputs, and 55% to those who provide post-farm processing, transportation, and distribution. Any questions? Yeah. Commercial inputs would include things like seed, things like fertilizer, fuel for tractors, that kind of thing. So Klautenberg argues that what we have seen is differentiation in agriculture, an increased division of labor, so to speak, and that this acts as a kind of primitive accumulation. In other words, productive activities have been displaced off of the farm and into industrial sectors. Now, perhaps the easiest way to imagine this is to picture a farm that grows both crops and livestock, and that cycles the crops into the livestock and the livestock manure into the crops, right? So that most of what the farm needs to produce a crop every year is available on the farm and does not need to be purchased. And this is a model that prevails in many parts of the world to this day, and it prevailed in the United States prior to the 20th century. So if you wanted to have a farm, you would have both crops and livestock. The livestock could help you pull the plow. The livestock could be fed some of the crops you grow. The manure from the livestock could be put back on the fields to fertilize the next round of crops, that kind of thing. What Klautenberg observes, and this is abundantly evident on farms today, is that more and more of these activities have gone elsewhere as farms have specialized in one or two crops. So instead of raising both cows and corn, you just raise corn. And you buy the fertilizer from someplace else. You buy a tractor instead of using your livestock to pull your plow, that kind of thing. This is a de facto, he suggests, expropriation of the means of production. It no longer is economical for farmers to do more than one or two different crops or activities, and therefore they sell their crop and use money to buy the things that they no longer produce themselves. This, Klautenberg suggests, turns the farmers into propertied laborers, which he's using that term very carefully as a kind of contradiction almost, summarized in that term. In other words, the laborer in a Marxian framework is defined precisely by the absence of property, right? The absence of ownership in the means of production. He's suggesting the farmer is a laborer, but is a propertied laborer. The farmer has been sort of forced to play a role that is subservient to the larger imperatives of the industrial agricultural economy. So that's his way of squaring this circle conceptually. This is based on the technological treadmill, an effect that we mentioned briefly last time in connection with Worcester and the Dust Bowl. As new technologies are developed for farming, they are adopted by some portion of the farming community first. They enable those early adopters or innovators to compete more successfully in what is a very highly competitive sector. Farms typically have got small margins. The number of farmers is very large. It's very difficult for farmers to organize and bargain collectively. Competition is quite fierce, and profitability is determined by their per unit cost of production. If you are able to adopt a technology that increases your production and reduces your per unit costs, you can profit handsomely from it. However, once everybody is doing what you're doing, once everybody has the latest tractors or the best seed, then you no longer have a competitive advantage vis-a-vis the other farmers. You're all on that new higher level of productivity, and you have to run faster to stay in place, hence the treadmill metaphor. And this parallels Marx's analysis of the falling organic composition of capital quite nicely. So how do you commodify a seed if it's a naturally reproducing thing? Klautenberg suggests that there are two ways to do this, biologically and socially. Biologically, it can be done if you can find a way to interrupt the seed's natural self-reproduction. And there are ways to do this that were invented in the 20th century. There is hybridizing seeds, which is to say creating seed whose next generation is viable but not worth planting. And that is the case with hybrid seeds for corn in the United States today and much of the world. There's also ways more recently developed to engineer the sterility, to manipulate the genetic makeup of the plants so that the seed will grow, but the seeds that those plants produce will not. They will be sterile, and they will not be able to produce another generation of crops. You can also commodify the seed socially if you can make seed varieties private property and then make replanting them illegal. Now, everyone comfortable with what a seed variety is? No? So, and this has to do with taxonomy. There are species, subspecies, which are considered different in an important genetic way, and then within subspecies there are varieties. Now, the idea of differentiating species is that they can't mate with each other and produce offspring. So, unless two things are of the same species, they can't possibly breed. Subspecies are recognized as biologically distinct within species, and then within subspecies you have varieties. And these are essentially relatively stable mutations that could interbreed with each other, but which have developed specific traits that make them different enough to call them different varieties. And this is something that comes up with plants much more so than with animals. But you can, to some degree, think of it in terms also of the development of breeds of cattle or dogs, for instance. Right? They are varieties. They can be bred with each other, but for various reasons, people go to trouble to make sure that they don't interbreed and thereby preserve the sort of purity of the variety that is whatever, Doberman Pinschers. Now, if you can establish some kind of private property claim to a variety that you have developed, and then get the government to back your contention that if somebody buys that from you, that's fine, but if they then reproduce it, replant it, that's not, because they haven't paid you for it again. That would be a way of commodifying the seed. It would be kind of like saying, I'll sell you this puppy, but if you breed this puppy again, you can't sell its offspring without my permission, without paying me something. So this happened, but not very quickly and not very thoroughly in the United States. The Plant Patent Act of 1930 did not cover a lot of plants. It only covered asexually reproducing plants. The Plant Variety Protection Act of 1969 applied it more broadly. There was a Supreme Court case in 1980 that's quite famous, the Chakrabarty case, which upheld private property claims to manipulated genes in plants. And this was actually in the newspaper just the other day, that a genetic feature pulled out in the course of some cloning experiments was challenged. It was developed by a private company in partnership with a university. And the federal judge actually upheld the challenge, saying that this was a naturally occurring sequence of genes and therefore could not be patented. And this is the debate that has gone on ever since the discovery of DNA and genetics at that level, that are these things the result of human labor that you can identify who did it and say that it's theirs, and they therefore own it? Or are they simply the heritage of the genetic makeup of the organisms of the world? They were provided by nature. No one can claim some kind of private ownership of them. And Kloppenberg details this debate at some length. It's time for a quick break. Boy, I have a long way to go, don't I? Okay. Let's pick this back up again. So, talking about the division of labor in agricultural research. Kloppenberg makes the case that scientific research and development have been key to the penetration of capital into agriculture in the United States. And this is in many, many forms. This university was founded as a land-grant university. It's now called the College of Natural Resources rather than the College of Agriculture, but it's right here in this building. There are similar colleges scattered across the country, and they are institutions relevant to this story. Lots of different things have been done using science and research in relation to agriculture, including germplasm collection. And here, by germplasm, we simply mean seeds, the testing and developing of varieties using those seeds, the development of technologies for breeding seeds, such as hybridization and genetic engineering, and the development of industrial applications for crops and of crops suited to new farm technologies. So billions of dollars have been poured into using science to improve the production of agriculture, create new markets, develop new technologies and products, and spinning them out into the economy from centers of research such as this university. And in Kloppenberg's estimation, industrial agriculture in the United States would not exist in the form that it exists today if it were not for this work. He wants to know who has done this research, who has paid for it, what kinds of research have been done by public and private sector researchers and institutions, why have they done the research that they've done, and how has the division of labor between public and private sectors changed over time, and why. He runs us through this history of sort of major landmark moments in the development of United States agricultural science, beginning in 1819 when the Treasury Secretary instructed consuls to send plants to the United States. So the diplomatic corps was ordered to wherever they were in the world to collect seeds that were used in agriculture locally and send them to the United States so that they could be collected and evaluated for possible use in the U.S. In 1839, the U.S. Patent Office got involved with this, which seems perhaps a little bit odd that the Patent Office would care about this. But again, this was viewed, Thomas Jefferson, among others, viewed the collection of seeds from other parts of the world as an absolutely imperative public good, that this was critical to agricultural production in general. In 1862, perhaps the most important of these was the Morrill Act, which created and authorized land-grant universities with federal support, and also created the U.S. Department of Agriculture. If you go to the library and start looking at the stacks, you will find many, many, many meters of shelves filled with the fat volumes produced by each and every agricultural experiment station from across the country and cycled through the USDA and this network of institutions full of the results of this research, going back all the way to the 1860s. The Hatch Act of 1887 created federal support for state agricultural experiment stations, and the Smith-Lever Act of 1914 created what we call cooperative extension, a county agricultural agent system. When we say, cooperative extension, if any of you are familiar with it, you can, if you're a farmer, or for that matter, even if you're not a farmer, you can call your local county extension office and ask them questions about soils, plants, climate, pests. If you've got a bug in your yard that's causing you problems, you can call the county extension office. It's called cooperative, not because the people who work there are cooperative, although usually they are. It's called cooperative because it represented a new relationship between levels of government. It was a cooperative undertaking by the federal government, state governments, and counties, which was novel. And it was so novel that they built it into the name of the entire system. Okay? Now, it's important to understand what previously had been the means of improving seed varieties. And this is the method of simple mass selection, which is the collection of germplasm from around the world and across the country, undertaken, as said already, by the government. And then it's free distribution to farmers across the United States. This was brought into being in the 19th century. All these seeds got gathered, the government collected them, and then they put them in little packets and mailed them free of charge to farmers. And the farmers then planted them, if they wished, and they saw what happened. And if it worked well, they would notice, and they would collect the seeds from the plants that did best and replant them. Perhaps they would communicate back to the government and say, wow, this really worked. If they failed, they just failed. This went on for decades across the United States, and it eventually led to the evolution of locally adapted varieties of seed, both for crops that were already being grown and for crops that were completely novel and had not been tried before. So when Worcester points out the improvement of winter wheat varieties by the bringing in of a variety from, was it Russia, I believe he said? That was an example of this. The government found this variety of wheat, distributed it to farmers, and lo and behold, it worked. Now, obviously, those seeds are going to continue to mutate and continue to be selected, and part of their mutations will reflect their relative adaptiveness to the local conditions. So you can imagine this is essentially thousands and thousands and thousands of experiments, and gradually varieties emerge that are suited to local conditions. This is enormously redundant. The vast majority of the seeds undoubtedly failed, or at least were not considered successful enough to warrant replanting. But it was also enormously effective simply because of its enormous scale. If you multiply together the farmers, the varieties, the sites, and the years, you have such an enormous sample of experiments being conducted that undoubtedly you will hit upon a few that work well. And if they do, they are essentially freely reproducing after that. All you need is the farmer to decide that it worked, hold the seed, replant it, and over time it will only adapt further in response to local conditions. The ones that are successful will no doubt be noticed by their neighbors, who will then perhaps decide to plant the same variety themselves. Yeah. Do they send the same seeds to every farmer? No. I believe that they made an attempt to sort of estimate or approximate which seeds were relevant in which parts of the country and send them to those parts of the country. They were dealing with far too many different kinds to be able to provide them all to everyone. And meanwhile, they were also the government agents for themselves. Once the USDA was created, one of the first things the USDA did was create gardens in Washington, D.C. and elsewhere, where they would plant these seeds and harvest the results and keep generating more and more of them. Some seeds, they'll go bad if you don't plant them and harvest them again and plant them and harvest them again. So this was a sort of early form of banking seeds and testing them. Yeah. Okay. Well, I don't think they're all mixed together. I don't know, Nathan, have you looked into this? My guess, you know what seed packets look like when you buy them from a nursery, right? I mean, it's a little teeny envelope this big, it weighs almost nothing, right? It may have a dozen seeds in it, or it might have hundreds, right? Because a lot of seeds are really small. And that might be enough to plant just a small garden, or it might be enough to plant some corner of a field, something like that. I believe that part of the reason this worked is that seeds are so light in those kinds of quantities. And if you were talking about 50 pounds of seed, I don't think the government was going to pay that cost for free. And as far as were they all mixed together? No. I mean, precisely the point here was to actually provide different varieties. So all of your packets might be seed to grow the same kind of plant, same kind of crop, but they would be separated out. You would get this variety of wheat, which we've collected from wherever, and another one is in a separate packet, that kind of thing. I mean, there was the intention here from Jefferson forward, literally, was to gather in the varieties of crops from around the world and give them to American farmers to see how they might work in American conditions. There would be potential for crossover depending on how the plant breeds, pollinates, that kind of thing. Yeah, but pardon? Okay, so it's self-reinforcing. Selection produces adapted varieties. Continued tests ensure genetic diversity within land.